It is fairly easy to measure a friction coefficient by putting an object on an incline and by changing the angle of the incline, increasing it. This is the angle alpha. You increase it to the point that the object starts to slide down. Here is the object. This is the gravitational force mg, which I will decompose in two forces. One in the y direction, which I always choose perpendicular to the surface, and another one in an x direction. You're free to choose this plus or this plus. I will now choose this, the plus direction. I'm going to decompose them. So I have one component here, and this component equals mg times the cosine of alpha. And I have a component in the x direction, which is mg sine alpha. There is no acceleration in the y direction, so I can be sure that the surface pushes back with a normal force n, and that normal force n must be exactly mg cosine alpha, because those are the only two forces in the y direction, and there is no acceleration in the y direction, so this one must be mg cosine alpha. Now this object wants to slide downhill. Friction prevents it from doing so. So there's going to be a frictional force in this direction. And as I increase the tilt, this frictional force will get larger and larger and larger, and then there comes a time that the object will start to slide. Let us evaluate that very moment, that it's just about to break loose. I'm applying Newton's second law. In this direction now, the acceleration is still 0, but the frictional force has now just reached the maximum value, because I increase alpha, so this component will get larger, and this component will get larger, this component will get larger, this component is still holding its own, but then all of a sudden it can't grow any further, and it starts to accelerate. So Newton's second law tells me that mg sine alpha minus ff maximum at this point is 0. And this one is mu static times n, which is mg cosine alpha. This one is mg sine alpha. This equals 0. I lose my mg, and you see that mu of s equals the tangent of alpha. It's that easy to measure. So you increase the tilt. We will do that later until it starts to slip, and then at that critical angle that it starts to slip, you have a value for mu of s, for the static friction coefficient. It is very non-intuitive that this friction coefficient is completely independent of the mass. The mass has disappeared. Think about it. It's very non-intuitive. If you double the mass, the angle would be the same, given the fact that you have the same kind of object. The friction coefficient only depends on the materials that you have, the materials that are rubbing over each other. It's also independent of the surface area that is in contact with this incline, which is equally non-intuitive. It's very non-intuitive, but we will see that that's quite accurate within the uncertainties that we can measure it. If you have a car and you park your car, you throw it on the brakes and you put it at an angle and you increase the angle of the slope, the friction coefficient for rubber on concrete is about 1, so the tangent is 1, so the angle is about 45 degrees. So if the road were 45 degrees, the car would start to slide. Independent of the mass of the car, no matter whether it's a truck or whether it is a small car, independent of the width of the tires, doesn't enter into it, even though you may think it does. They would both start to slide at the same angle, given the fact, of course, the same road and the same kind of